Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, which is for my first-year honors chemistry students, we're talking about factor label and how we can use this strategy, which is sometimes called dimensional analysis, to solve problems that are generally involving conversions from one set of units to another. Right? It's a really, really important skill. I'm going to tell you, students who master factor label do better in chemistry. It's that important. You really need to know how to do this. So, let's start by talking about conversion factors, right? For example, we know how many seconds are in a minute. We know that there are 60 seconds in a minute. This is a definition, right? We know that 60 seconds is the same amount of time as 1 minute, and we can have conversion factors. We have a lot of conversion factors. All your metric prefixes, which I really, really want you to know, we can use those for conversion factors as well. Centimeters to meters, meters to kilometers. There's all kinds of them, all right? But anytime I have an equality like this, where I have different units for an equivalent value, I can write them as two ratios. If I want to convert between these time units or convert between whatever these units are, I'm not limited to doing it for time, I could write 60 seconds over 1 minute, or I could write 1 minute over 60 seconds. And they're both equally good. The question becomes, which one will I choose? And that will depend on what kind of conversion I need to do. All right, what do I want to end up with? All right, so anytime I have an equality, I could write it as one of two ratios, and I'm going to choose what's in the numerator and what's in the denominator of that ratio, depending on what I need to do in terms of my problem. Let's talk about a strategy that we can use to set up these problems and to do them. Before I do that, I just wanted to mention that for our metric prefixes and for these definitions, days to hours, hours to minutes, those are exact numbers because they're definitions, and they're not going to affect the number of significant figures in my final calculated value. Occasionally, we do have situations where the conversions might depend on measured quantities, and then we would have to consider that. But for most of the problems that we're doing, the significant figures in the answer will depend on the significant figures in the given quantity in the problem. So let's talk about strategy. The first thing I want you to do is read through the problem and identify what you know. What are you solving for? What are you given? And then use that to figure out what conversion factors will take you from what you're given to what you need. All right? You can then think about what those equivalent values would be so we can set them up. After we've got that information, we're going to set up the problem. We're going to set up our factor label problem so that the units we don't want cancel, and we're left only with the units that we ultimately need. I tend to write these from left to right. I tend to write them so I'm working sequentially from left to right. That's not a requirement. What's important is that the correct units get canceled and that correct conversion factors get used. But being systematic can make that a little easier to do. And then, and only then, will I get out my calculator and do the math. So I'll make sure my answer makes sense. Was I expecting a bigger number? Was I expecting a smaller number? Sometimes that's very clear from the setup of the problem. And then I'm going to make sure my answer gets reported with an appropriate unit and the correct number of significant figures, which is generally going to be based on the value given in the original problem. So let's actually do some problems. We're going to do 3 problems right now. How many seconds are in 8.2 years? Okay, so let's go through our strategy. All right, what am I solving for? I'm solving for seconds. What am I given? I have 8.2 years. I need to know the equivalent number of seconds for that amount of elapsed time. All right, let's think about conversion factors. I don't have a conversion factor that goes directly from years to seconds. I do know years to days. There are 365 days in a year. I know days to hours. There are 24 hours in a day. And I know hours to minutes. There's 60 minutes in an hour. And I know minutes to seconds. So I have the information that I need, and now I can start setting this problem up. So let's actually do that. Again, I want the units to cancel that I don't need anymore, leaving me only with seconds if I'm all set with the problem. I always start this as x what you're solving for equals what you're given. X seconds is equivalent to 8.2 years. So let's think about our conversion factors. I can do years to days. All right, there are 365 days in a year. I can do days to hours because there are 24 hours in a day. I can do hours to minutes. There are 60 minutes in an hour. And I can do minutes to seconds because there are 60 seconds in a minute. All right. If I've set it all up correctly, I should only have seconds left. The units will cancel. Oh, years cancel. Days cancel. Hours cancel. Minutes cancel. I'm left with only seconds, which is what I want. All right. And now I can get out my calculator and do this. So I need to do 8.2 times 365 times 24 times 60 times 60. Turns out in this particular problem, all the denominators are 1. So I really just need to multiply. So I'll get out my calculator and I will write that down. All right. And I do want to make sure that my answer is reported with the correct number of significant figures, which should be 2. I had 8.2 years with 2 sig figs, so my answer should have 2 sig figs, and my units will be seconds. So I do that, and I get 2.6 times 10 to the 8th seconds. Notice it's a really, really big number on your calculator. I only get 2 sig figs, and because it's a really large number, I chose to write it in scientific notation. You could, of course, write it in standard notation. Make sure you've got all your trailing zeros, but I wanted to make it clear that there were only 2 sig figs, so just be careful about that. All right, let's go on and do another problem. An automobile is traveling at a rate of 30.0 kilometers per hour. What is its rate in centimeters per second? So, what am I solving for? Centimeters per second. What am I given? 30.0 kilometers per hour. So now let's think about conversion factors. I need to get from kilometers to seconds. And you might know that conversion factor directly, and you can use it that way. Or I thought about it as kilometers to meters. There are 1,000 meters in a kilometer. And then I thought there are 100 centimeters in a meter. So I can do my distance conversions, and then I need to do time conversions. I need to do hours to minutes and minutes to seconds, like we did in the previous problem. So now I can start thinking about setting up my problem. All right, so again, x, what I'm solving for, equals what I'm given. All right, so how many centimeters per second are equivalent to 30.0 kilometers per hour? So I can convert my hours to minutes, and I can convert my minutes to seconds. And then I can do my distance conversions. I can do kilometers to meters, and I can do meters to centimeters. Have I set it all up correctly? Let's check. Hours canceled. Minutes canceled. I'm left with seconds in the denominator, and that makes sense. I wanted centimeters per second. Now let's check the distance ones. Kilometers cancel. Meters cancel. I'm left with centimeters in the numerator, so ultimately I'm left with centimeters per second, which is what I want. So I think I have the problem set up correctly. Now I can get out my calculator and do that. I get 833 centimeters per second, and of course I want to have appropriate units and sig figs. So I had 30.0 kilometers per hour, that's 3 sig figs, so I can report my answer with 3 sig figs, and my units are correct, and it makes sense. All right, so make sure that you know how to set this up and do this in your calculator. I just keep punching things in until I know that I've done it correctly, and round for significant figures at the very end of the calculation. Don't even worry about that till the very end. All right, let's do one last problem. This problem is actually really important. An object has an acceleration of 3.2 meters per square minute. What is its acceleration in meters per square second? So we have to be careful here because we have square units. All right, what am I solving for? I'm solving for meters per second squared, and I'm given 3.2 meters per minute squared. So I highlighted the wrong thing, so that's fine. I'm not going to let that throw me. All right. In terms of conversion factors, I need to get from minute squared to second squared. But what I have to remember is these are square units, and I have to set this up correctly, otherwise it won't work. All right. So x, what I'm solving for, equals what I'm given. All right. But what I want to point out is that, right, it's minutes squared. We can think of that as meters over minutes times minutes. And I'm writing this out deliberately with these square units because otherwise students tend to not do these conversions correctly. All right. So I need to convert from minutes to seconds twice. I need to calculate that conversion and put that in twice in order to make my units cancel properly. So I have to do minutes to seconds and then do it again. All right. Because that's what the math requires. All right, that's what the units require. I need to cancel out minutes again and do it again. All right, and that's how I end up converting from square minutes to square seconds for my acceleration. All right, so I have to do 3.2 divided by 60 and then divide by 60 again if I'm going to set these up correctly. All right, and now I can do my math. I'm expecting, an answer that's really pretty small. All right, compared to my answer. All right, and I should have 2 sig figs in my final answer. All right, so it's really important that you pay attention when you've got units that are squared or cubed, that you're canceling out and doing those conversions sufficiently. You're doing them enough times to make all the units cancel out. That's a common mistake. So I'm going to end here. And this is something you're going to practice a lot, and you're going to have a lot of fun with. They're really important skills in chemistry. They're going to come back in later units, so don't think you can just forget it. You really need to get good at factor label, and we're going to do a lot of practice in class.